This is the PowerPoint about latitude and longitude. The notes say finding locations on the Earth. Reference points. Points on Earth's surface used to establish direction. The north and south geographic poles are reference points. Plus the imaginary line dividing the Earth into the northern and southern hemispheres, called the equator. The equator and the north and south poles are all reference points. Latitude, another name for the word latitude, is parallels, because that's the way the lines run. They're imaginary lines used to establish north to south location. These circles run east and west around the world parallel to the equator. So if you think about the equator, another line above it and below it, lines of latitude that are also called parallels. And they measure the angular distance in degrees north or south of the equator. All locations north and south of the equator have latitude between 0 and 90 degrees. The latitude at the equator is 0 degrees. So at the poles, each pole is 90 degrees. The equator in the middle of the Earth is 0, does not have a north or a south designation. The North Pole is going to be 90 degrees north. The South Pole will be 90 degrees south. And each degree of latitude has an actual measurement of 111 kilometers. So per degree, each one is 111 kilometers. Some examples of latitude. 1 degree is broken into 60 parts, which we call minutes. I like to kind of think of this as time. Like a degree is sort of like an hour, because you can break an hour down to 60 minutes, just like a degree can be broken down into 60 minutes. Each minute of latitude is 1.85 kilometers. Each minute is broken down into 60 parts, which we call seconds. So again, it's like time, because you can break a minute down into 60 seconds. And then each second of latitude is equal to 0.03 kilometers. So we're getting more and more specific. If you think about an hour, that's kind of broad. Then you can pin down to minutes, and then even more specifically to seconds. And Washington, D.C.'s latitude is 39 degrees north, but that's still sort of broad. So if we want to get more precise, we can include the minutes. Oh, you know what, there's a typo there. 38 degrees and 53 minutes north would be more precise, or 38 degrees, 53 minutes, and 51 seconds north. So keep in mind, we've got the degree symbol here. This little 1 dash mark, or maybe another word for that, apostrophe. 1 apostrophe represents minutes, and then if you come down and look at seconds, a quotation mark, that's going to represent the second symbol. So you've got degrees, minutes, and then seconds, and those are the symbols used for it. Longitude. Another word for lines of longitude are meridians. They're imaginary lines used to establish east-west location. Each meridian is a semicircle running from pole to pole. So from the North Pole to the South Pole, and from the South Pole back up to the North Pole. The meridian passing through Greenwich, England, is called the prime meridian. And that one's got a 0 degree designation. Just like the equator has 0 degree designation, there's no east or west to go with the prime meridian. It's just 0 degrees. And these lines of longitude measure the degrees east or west of the prime meridian. All locations east and west of the prime meridian have a longitude between 0 and 180. So again, I already said the prime meridian has the 0 degree designation, but I wonder if any of you know the name for the 180 degree line. Some lines of longitude. Here we'll keep talking about DC. DC's longitude is 77 degrees west. And again, if we want to get more precise, 77 degrees and 0 minutes west, because we're in the Western Hemisphere. Or if we want to get even more precise, we've got 77 degrees, 0 minutes, and 33 seconds west. So DC's actual location, 33 degrees, 51 minutes, 51 seconds north, 77 degrees, 0 minutes, 33 seconds west. And which one comes first? Is it latitude or longitude? If you're going to write out the way coordinates are said, think about it as alphabetical. Latitude is higher up in the alphabet because of the A than longitude. So the latitude number always goes first. Great circles, another imaginary line used in navigation. A great circle is any line that circles the Earth, dividing it into 2 equal halves. So let's think about some examples. The equator divides the Earth into 2 equal halves. The prime meridian, all the way around to the 180-degree line, which I want somebody to come back and give me the name for. That would be a great circle. If you think about the Tropic of Cancer or the Tropic of Capricorn, those are not great circles because they do not divide the Earth into 2 equal halves. Let's take a second to find out where we are located. Our location in Newport News, south of DC, so the latitude will be lower because we're closer to the equator, 37 degrees north, and our longitude is 76 degrees west because we're closer to the prime meridian over towards England than DC is. So both of these numbers are lower than the numbers for DC. Finding direction. Use a magnetic compass to indicate direction. A compass points to geomagnetic North Pole, which is at an 11-degree angle from the geographic North Pole. True north and geographic north are the same, but this magnetic north is actually different. What's going on at this point is that the North Pole is actually shifting to become the South Pole, and the South Pole is shifting to become the North Pole. Well, it doesn't happen very often. Thousands and thousands of years between these shifts. And that's what's happening right now. We've got this 11-degree difference because the poles are actually shifting. And they reverse every once in a while. So that's what's going on here. That's why we have the 11-degree difference. Don't forget, you've got to go back and write down some questions. Make sure you bring 2 good, thought-provoking questions that you do not know the answer to class, so that in case someone already has one of your questions, you've got a backup option. Make sure you do not already know the answer to the questions. There must be something you don't know, and you maybe don't think anybody else knows the answer to either.